All right, howdy, folks, and welcome to Alwa's NES Awakening. This is stream number 7. My name is Paul, go by InfiniteNesLives online, and we are porting Alwa's Awakening to the NES. So, last time we had the name tables being loaded up into our C project, and we don't have our attribute tables, but we have our output of tiled being converted from Lua to binary, and then we imported that into our project, our C project. And today I figured we would try to get the attribute tables converted. We'll see how that goes. And maybe I started to question my choices on if I wanted to really do this as in C or assembly. We might play around with some assembly and kind of see how that feels. But we'll see how far we get this attribute table stuff here. So, my general idea here is to use custom properties of the tiled tile set here and assign a palette number, and then use that to generate attribute table data. So let's look at, this is the output of tiled in Lua format, and here we can see the tiles. It gives the ID and then the palette number. So let's see. Our palette assignments, pull that up here quick. We'll kind of have it here, I think. 0 is green, 1 is stone, 2 is dirt, and 3 is sky in general. And that's gonna, we may push those rules a little bit. So let's assign some of those things. Even though this board stuff here isn't quite right. I wonder if I can set them. So this is supposed to be number 1. So that set all of those to 1. These should be sky, which is 3. Okay. That mostly looks right. Some of these up here. are not getting changed. I don't know if I'm changing them as I actually had that somehow set before. What are these? I don't know what I have to do to get that change to take. Oh, I think these are actually the trees. Are gonna be three as well. Should be 0 for the green. Dirt is supposed to be 2. Okay. And these guys, 1 gray. Okay, let's save that. Okay, we got some 1s, 2s, 3s, and 0s in there, it looks like. How cold? It's actually pretty warm today compared to what we've had. It's only -7 right now, so I'm sure it's considerably colder than what you've got there, Brian. Yeah, well, it's better than what we've dealt with for the past couple weeks. Either that or I'm just finally getting used to Minnesota winters again. It's been like the snowiest winter they've had here in a long time. Okay, let's see here. So we need to get access to I was creating a file nametable.bin and then writing the tiled .layers1 and then data. What's tiled? Okay, test.2. I just named it tiled. So tiled doesn't have any rules to abide by the attribute table rules of typical NES. For now, my thought is just grab the top left tile, the palette of that top left tile, and assume that we drew the screen properly and the other 3 tiles are correct. Now maybe we could build in some additional information there. Let's open a new tab. Okay, so there's some test prints in there. I don't think I actually use this 2-hex. Whatever. What is my... Okay, so I was printing it out here. I print out the first tile. So we need to take that's the tile number. Now we found an issue that it was off by 1. The first one's 2, we ended up subtracting because I guess they Luified things for us. So the first tile is oh 241, but they print 242. But the interesting thing is that when we look at the IDs here, the IDs are 1 through 0 through 255. So the IDs are the IDs as it shows here, 0 through 251. What is that? Oh, I don't see the whole thing. That's why. There. Tile 0 through 255, but for whatever reason, yeah, encoding Lua. Maybe that's why it's opacity, offset, ID 1. Anyway, all the data is off by 1, but everything else is right. So we want to, we're printing the first one. Oh, but actually it's, oh, data 2. Data 1 is 242. So yeah, so the first one is tile 241. Now we want to use that number. We want to print the palette of tile ID 241 or whatever tile ID is. So how do we get access to that guy? So it's tile sets. Tile sets, tiles, ID, and then one of the properties. Okay, so tile sets. And then we had that issue where we had to tell it the first one because the first, yeah, they have this double semicolon. So tile sets or curly brace. So tile sets 1, and then tiles, and then there's a superfluous curly brace here, but this is tiles 1, and so we want tiles tile ID. So that, and then we want that one's properties. Well, we can maybe, just to be simple, let's print the ID, and then it should be the same number. So it's 1 less. Oh, because okay, yeah, that's because it's Lua. So I subtracted 1, but then we don't really, okay, so it's not tile ID. This is really tile Lua number. Gosh, why do they think they're doing us favors here? So the ID is the, well, let's not call it Luma's data num, because really it's only data. Well, data, and then if we're accessing it this way, let's just do num and ID. So num is Lua is 1 index and ID is 0 index. So then we want the actual number. $16. Okay, so data is 242, which is the number. The ID is one less than, and the property is 241, which is actually the ID. We're printing the ID. So we have the property ID. We want the properties. And then if we give it the key palette, it should give us 0. But what is that? Is that... Yeah, so I think that's a... What if we just print 1? Let's try 1 first. Nil. Properties. Let's give it palette and see what happens. Make sure I'm not being dumb here. Okay, 241. Do we have to put that in? There we go. Okay, it needs the quotes because we're giving it a string key, I guess. Not enough Lua to get myself in trouble here. Okay. So 241 is indeed palette number 1. Let's do some tests here. So let's do tile number 1. And tile number 33. Tile number 133. So we're going to give it one on either side. And then this is tile number 192. So 193. Okay, so 0, 0, which is 1 and 32. Yep. And then 2, 2, 3, 3, 1. So this should be 2 for 33, 132. Okay. I think it's working. And then we gave it 190. There should be 3. And then a 1. Okay. So that gives us the pallet number. So let's create so we've got an attribute table file, and here with each tile we just print the tile number. So for B, for byte in data, so we can use so if B is our mod operator. I don't know if there is. Oh, there is. So this is going to be one index. B minus 1. And if not, B minus 1 mod 4. Oh, wait a second. This is going to be counting like this. So maybe we just want a counter that we can use. So row and column is 0. Or no, column. If column equals what's this? Oh, bottom left, 0, 0, 0, 31. Yeah, so 31 tiles per column. And then we have 26 rows, 0 to 25. So 31, 25 are the so column equals okay, so if column equals 32, then we increment the row and set column back to 0. Now, if column, or no, row, so if the row is even, I'm just going to do this. If not row mod 2, then so if it's 0, then the modulus would be 0, which would be false. So how are we doing, Menshaku? I think I'm getting this logic right. We have an even row or column. Row. We have an even row. So this is when we want to pay attention to let's just do that. Tester 3. And column, the column also has to be even. So we should to perform arithmetic on Boolean. Oh, thanks, yeah. Teak in French, yeah, my hat. It's my Luigi beanie my brother and his fiance gave me for Christmas. I wore it the other day a couple weeks ago when I was sick on the stream. But I decided with the temperature down here that help keep me warm. Okay, what did I do wrong here? I did arithmetic on a Boolean on line 71. Oh, yes. I don't think we can. So if row mod 2 equals 0, I think we got. I don't know if this is how you have to do it, but like C without the conveniences. Okay. I think we did it. Oh, but we missed the first one because we incremented it first. Yeah, it looks like it's working. So, yeah, don't. Okay, so now I think. Well, I did column first because I keep getting mixed up. That's why. Okay, so we have row 0, 2, yeah. 30, 0 is going to be the last one. 30, 0, and then we don't have anything for row 1, and then row 2, 0 through 30. Okay. So looks good. And we have row 0 through 24. I'll bring the comments over here for now. Why not? All right. So we've got our counters. Oops. Sorry about that. Yeah, so it's even row and it's even column. I think B is going to be 1 indexed, so it'll be 1. Yeah. 1, 3, 5, 20. Yep. And then here it's 65. So B is the number, which is 1 indexed. So So it should print the palette number with B. Okay. Oh wait. No, that's not right. So that's the name table index is what B is, but we want the tile number, which is what we wrote. So let's so tile num equals tiled layers 1 data B, and then tile ID equals tiled num -1. And then we write string to char tile ID, which is probably right. So we have the tile number, tile ID. So we want to look up of this tile num. So print the palette. So do we get it? The first one is supposed to be palette number 0. Palette 1. Oh, wait. 0, 0. Tile number 241. Oh, I didn't print it. I'm not 100% sure that I have that. Dang it. So tile ID 241. Yep. Property palette 1. Yeah. Okay, I don't know what happened last time. So we got a whole lot of ones. Until we get to the sky. Which should be somewhere around 8, 11. Row 8. All of these say 1. Did I not save the changes? It says 3. Oh, there we get some. Row 12. 3. Oh. Getting my row column mixed up. So this is, yeah, okay, so it's row, or yeah, row 11, which we don't see it. We don't actually see it to here. 12. And we start getting some 3s. Okay, and then so around 16, we should start getting some 2s. Get some 1s again. Get some more 3s. Okay, that looks right. Probably good. We'll just move forward. So we have the palette number. Now we have to put that in attribute table format. And what does that look like? So it starts at the top right again, or top left. No coffee. So if this is the top left, this is the first byte of our attribute table data. The first tile is going to be bits 0 and 1. Trying to think of how we want to construct this. Part of me says first write it to a file that is not bit packed into bytes. It's one entry per byte, and then come back through and bit pack it. Did we write it to the file? Probably not. So pal that's not gonna be right. We're gonna run into console's not gonna like me doing that. Let's close that file. And that one. Let's just go ahead and do it anyway. So right palette. I don't know if that's a string or a number. I don't know if Lua cares if there is such a difference. I don't think there is. Let's just see what we get. Okay. That looks right. We have a bunch of 1s, 3s, 2s, some 0s, and a bunch of 1s. I think it's going to be the same format. String to char pal. Okay, so we wrote the binary number. See, this is attribute tables are 64 bytes, 64 byte array. Oh, I'm missing the heads up display. But if we had it, we're basically 4 times too big, which is what we expect. Because we're not bit stuffing. So this might be easier to bit stuff in Lua. Part of me says we want to iterate through this twice. Once to create the name table file, and once to create the attribute table. Because to create a byte, we need to skip ahead to the next set of rows. Because our first byte needs this is actually 4 tiles. One attribute table block. So this would be row column 0, 0. This is still row 0, but it's 2. Yeah, so each one of these is like this one, this one, this one, this one. We already have it not bit stuffed. Inner attribute table. I think it's going to be easier to bit stuff it after we've created this file. So all of our information is already there. So adder bytes. Names are terrible here. So adder byte file. So that's the byte file being written to. Make sure we're closing out our files. Okay. Okay, so there's our byte file. Now, so close those files. And then we want to reopen. We want to reopen the adder byte file, but we want to do an in read binary mode. In the attribute table, open that and write binary mode, and then okay. I don't think I want this in a file. I want it in a table, because then I can just index it. In a file, it's a pain because of the file pointer, or you read the file sequentially. We want to just have all this data in a table, in an array basically, and then get that data out of the array. We'll still create the file because we already did it. So So adder array. So we say we can use whatever we want for the keys, the key pairs. Part of me says it'd be nice to have a separate array per row. But not really. Okay, so I don't know if about tables. Don't think that's gonna work. I don't think this matters how I instantiate it. So we want a table of tables. I think we can say row row.call equals pal, but here we want to print array 0 0 0. Index field row, a nil value. 79. Why is it nil? Oh. No, row. Oh, wait a second. I think I need to put it in quotes because it's the field row. That's the difference. So wait, what? Create a table. K equals X. So that's like my... Oh, the keys are strings. Or you can index them based on number. So you can give it a key or a number. Okay. So K equals X. AK equals 10. A new entry of X equals 10. A 20 equals great. The key of 20 equals great. Print A of X, which is set to 10 here. A of K equals great. Well, why? Let's try to not do row and palette at the same time, or row and column. Because I think I can just do array.row equals palette. And then I had a problem where I indexed it improperly. I don't think I want to do that. I think I want array row equals palette, row equals 0, or whatever it happens to be. So then 106. Oh. Is it just that killing me the whole time? I have it right the first time. And then my junk messing me up. prevent all that trash. Oh, we don't actually have a column. I don't know, we should. Line 79. What? Okay, so we set row. I don't know if we're gonna have a two-dimensional table. Two main ways. The first is use an array of arrays that is a table wherein each element is another table. Yes, that's what I want to do. For instance, you can create a matrix of zeros. I think I have to actually instantiate it. And then I can do it. Which is what I was thinking, but that was just a guess that I assumed would be wrong. Okay, so if I keep reinstantiating, I think it's gonna mess it up. Because tables are objects. Yeah, you have to create each role explicitly. Yeah. maybe not. Okay. So let's just instantiate it and see what happens. I think it might clobber it. So row equals a table, and then we can say nil. I think we let's just create it. And then we can use it. For one, and we don't actually have the entire, shouldn't have to do the entire attribute table. But maybe let's just go ahead and do it and then trim it back. So it's 8 by 8. So 1 through 8. For I, for J, oh shoot, it's 8 by 8 for the attribute table itself, but it really it's 60. It's twice that. It's 16 by 16, but really not, because this is we'll just say it's 16 by 16. So we got a 16 by 16 attribute table. And now we can just use it, I think. 90. Nil value. Oh, I think because it's 0. God, this is a pain. Normally you could just deal with the fact that Lua is one indexed, but the NES is not one indexed, and so I'm having to deal with that fact constantly, I think. No, but we... Oh, we can, I think we can just do this. It's still not gonna work. And why? Why is it nil? What the hell? 91. Attempt to index a field of nil value. Sure don't look like nil to me. Do I have to put it in quotes? But it's... Oh, maybe that is it. That's gonna make indexes of roll call though. That there I can say 0 0 equals pal. Why can't I say oh because I get it. We created a 16 by 16 row or 16 by 16 attribute table array. When we give it column 30 or whatever, then it's wrong. We didn't create a 30 by 32 array. We created, okay. So we need to divide by 2. Okay. Alrighty. Alrighty. So we have our array. We should have the data in it kind of similar to how we printed the file. It should kind of look like this. So now with that array, and this is indexed 0 through 15. And there's not actually, there's only 14, but I think there's a few extra bits that are basically unused. Excuse me. Because it's a 64-bit array. But the last row doesn't exist, because that's where the attribute table is stored in relationship to the name table. Okay. We still have to create it as if it's there. And tiled isn't actually creating the first 3 rows, or the first 4 rows of tile data, because that's our heads up display. So we write it, but we don't actually use it. Okay. So now we need to create these bytes. So we have 64 of them. So we have 64 bytes to create. So the first one is going to be this guy right here. So we want 0, 0. So temp, maybe we don't actually need to iterate 63 times. We just need to iterate. Or no, we have 64 bytes to create. That's right. So temp equals whoa. So it's I. We can reuse the row and the column variables here, except we're no longer thinking in so row column. So it equals this first one, which is D0 through 1, which is actually right. So we don't need to store in temp, we can store it in the byte. Okay, and then temp equals row we want the next one. Same. Oh no. Dang it. Column. But we could just top left equals bit right equals bits 2 and 3. So column plus 1 bit shifted over. It's awful quiet on the chat here tonight, but I think part of it's because I'm actually getting things working and nobody's having to tell me what to do. Feel free to ask questions or whatever if you guys have anything. So we want to get the bottom left. Now we need to, our row and column is still indexed here. So we just want to go down a row. So that's bottom left equals bits 4 and 5. So row plus 1, and then column unchanged, and bit shift that 4 times. And then bottom right equals bits 7 through 6. Which is both of them plus 1. Shift by 6 bits. Let's see. So that we could OR it in or we can add it in, shouldn't really matter. Except I have some issues of int. Well, let's just assume it. Well, let's add it in. Let's assume that works, but keep in mind that could be a source of problems. Okay, so the bytes created now write it. So that's the first byte. Now to index column and row for subsequent bytes. So column needs to increment by 2. if column equals 16, then column equals 0, row equals row plus 2. And that'll create 64 bytes, right? Yep, I think so. But I have for I 0 through 63. I never actually use I just use it as a for loop. I think that works. Well, I don't know. Probably doesn't work, but write the byte. Let's see what happens. Unexpected symbol. Well, you don't like my bit shift? What did you say about it? Unexpected symbol next to the caret. Yeah, this bit 32, bitwise operations. I might not actually have this installed. Thanks for the follow there, Gen Zoom. Let's see here. As a version 5.2, Lua ships with bit 32. Do I have to import it, or what do we, oh. Bit L shift. L shift returns A shifted by so many places. 2. Okay, so didn't complain until we got to there, so I think it worked. See if that worked. Yeah, attempt to index global bit, no value. I think I have to import the bit. I think I just do like require. Oh, bit 32 maybe. I think I just say bit 32. Oh, did we do it? Did something. Let's do 8 by 8. Hey, I don't know if it's right. It looks pretty good. So, oh, these are ones. Oh, looks pretty good. We don't have our heads up display. So let's save this as, well, maybe we don't need it. If when we go to update the name, well, the VRAM, the name tables, if we set the address of the update to 22D0, and then write those, what do we got, 30, because we're short. So I actually created all 64 bytes, but I don't have the heads up display data there. So we only really need 36. All right. Wait, no, 56. Heads up display, it takes up the first 4 tile rows. Which is this, the first 8 bytes. Oops, I don't know how I did that. Okay, so now we have 56 bytes. Wait, no, 58. Oops, didn't mean to do that. Dang it, just lost everything. Okay. I was trying to bring up a calculator. Okay, yeah, so 38. 56. Yeah. 56 plus 8 is 64. Yeah. All right, can't do math on stream. Okay, so we only really create our 56 bytes of data, which is all we really need for this right now. Okay, so let's import that to our project. Attribute table, so tiled. That's a bad name. Tiled at. So tiled attributes. Okay. AT data. $56 bytes. Excludes the hug. Okay, so VRAM right. We want 22C0. No, wait. 22C8. Let's see if this. See if this works. File. I don't think so. We just built it. Did not. Oh, something happened though. Look at that puke right there. I have that right? Oh. Why is this? Each attribute table starts at 23C0. I don't know what this number means, but it's 2-3, not 2-2. I thought this went in with that, but so 23C8 should fix it. Come on, meow. Go. Hey, we did something. We did something, okay. I think the pallets are wrong, but I might have never. Oh, we had that problem where the pallets are. What are our pallets set to? Palette. Tools. PP, UPR. Yeah, I don't know if I actually. So it's supposed to be 0F OBO. Okay, let's export pallets. Put C data to clipboard. Not impressed by my build time here. Well, is there just a reload? What? I just run. Come on, can I have to? Is this really... I don't want to run all this other debugger stuff. Anyway, it looks like we did it. Oh man, look at those vines. So we we didn't abide by the attribute table boundaries, so some of our dirt is blue and some of our clouds are brick colors. And we skipped over where the heads up display is going to be, so those should all be 0, which is our first palette, which is green. But man, those vines look cool, and the dirt don't hurt. Maybe update that guy to 37. But I have him on. Oh, come on. I think that's right. I gotta learn this debugger for messing. Keep opening over there. Yeah. Looking pretty fresh. I like it. Something's going on with our bricks. It's saying that, well, I think it might be something with that bug that I had. It was changing the color. But we kind of... That wasn't so bad. Kind of got some of the dust brushed off from Lua and all the importing, and so we just had to figure it out this time. I don't... So one thing I was thinking about doing was playing around with some getting an assembly program to this state. I like C, but the thing that I have a hard time... Let me hit my mic there. So anytime I could have a false understanding of, I'm kind of just assuming that I know what I'm talking about here, but the thing I don't really like is how, like, the stack, well, it's a this subroutine pop AX. Where's pop AX? CRT 0. InfiniteLib. There's like a, or maybe it's, I want to see what that actually looks like. Where's the NetLib? I don't know. It's is it in MC1 macros.asm? I don't know where it is. Anyway, we're using subroutines to get arguments. Like I mean, I know it's not that bad, but I have a hard time. I know I'm really going to be strapped for, well, I don't really know. I assume I'm going to be strapped for PC processing time, and I was just like, well, I get things working in C, and then I convert them over to assembly. But we have subroutines for fetching function arguments. Like, sometimes can we just have arguments in the AX Y registers, or I mean, we have our 256 registers of zero page. Can't we? I mean, it's just that's CC65. That's how it's set up, and I have a hard time getting behind that. And so, yeah. Times it 11:20. So I think I'm going to take a quick break here. All right, back from the break. We are using Brad Smith's CA65 example. I'll link to in the YouTube notes. He's just got this little bat file to build it. And so with the cursor, do some things, select to clear it. No sticky keys. And then you can scroll. So he doesn't actually Its main function. Okay, so here's our palette data. The main function has a setup background, and the setup background routine clears everything. Let's import patterns OpenCHR. So this is CHR. Just some simple stuff. OpenCHR, the sprites. It's really just the one sprite. Anyway. Okay, so there's no actual import of a background name table data. Hey, party time, excellent. How we doing? Thanks for joining us. So there's no actual import of background data. He's just clearing it. And then filling an area with checkerboard, and then a simple pattern. So the first task of assembly, and I am super rusty. Just by HXD taskbar. Yeah, we've even got it. Boom. We so I'm guessing you're just joining us, but we earlier we took our tiled. So tiled will export to Lua format, and we assigned we made a custom property for our palette. So I gave the different tiles a palette number, and we exported that to Lua, and then we took our let me show you here. So the Lua output just has all these tile ID, palette number, whatever I assigned to it. So we created an array of attribute table data, and then we bit stuffed that into NES format. And this is our little attribute table of my dummy test screen here. So that's what we got. This is our attribute table, and we imported that, and we've actually got it running. But now I want to try to, that was in our C project, so I want to try to play around with some assembly here, because I'm not sure I want to be in C. I thought I did, but after last stream I'm starting to question that. So we want to import I'm probably going to I don't know if I've ever actually used CA65. A little bit. I hacked Brad's project here to do something very basic once. But so name table, background. So these are our name table and attribute tables. Oops. So tiled name table, and I paste it in the HUD. Just a bin. And our attribute table. Okay. So we imported that. Modify our, I think rendering is still not on at this point. So we can do all this stuff before we turn rendering on. So the reset, the latch is reset, and then setting VRAM address to 2000. Setting 0, A to 0, 30 rows, 32 columns. So Y is incrementing rows, X columns. But we need to index to our source data. So maybe we'll do that with Y. I'm gonna be brushing off a lot of dust here. Yeah, doesn't really matter. We can do either X or Y. But we also need a row counter. Yeah. screen 0 name table and attribute table. So need to increment y. It's gonna take me a while to get used to these instructions here. My most recent assembly has been the STM8 microcontroller, which is very similar to the 6502. It has 0 page A, X, Y registers, but it's got a ton of other. It's a complete instruction set. So that will update a row. But it's only gonna, we got 2 KB worth that we want to update. A temp variable we can use. So if we use temp, how am I even going to do that? What I really want is a 0 page pointer. So I need the pointer to be set to the address of screen 0 NT. How? that. I think there's this thing, the immediate. I saw this, so I think this does the. I'm gonna look it up. So CA65. Yeah, returns the low byte. Is there a high? So caret right is the high. So pointer is a 2-byte, and 6502 is Little Indian, so pointer is the LSB. Pointer plus 1 equals MSB, I think. So turns the high byte. No, got backwards. Okay, so we have a pointer, if I'm doing any of this right. We got a pointer toward name table data. And so now we can just keep incrementing the pointer. If we have an overflow of the low byte, then we will wrap around and need to increment the high byte. So we can keep LD, can keep Y as the the row counter. Let's oh wait. Indirect. We need y to be 0 to use that pointer, or we could just add. We can use the so indirect x. I think that changes the pointer. The next 0 page address. This adds indirect, indexed, indexed, indirect. Rusty. Okay, so I think we want to use y for the column, and then we can add to the pointer. We can add 32 to the pointer each time. Oh, yeah. Counting down. Assembly, man. Okay. But I think that'll still work. Midnight. Suffer through this for a while. And I'm sure none of it will work, but be more educated on my decision on C or assembly. I'm for assembly anyway. I may as well get good at it. All right. It has to increment in the same fashion. So X can count down for the rows. Y has to count up. Is that how we do that? So LDA pointer Y, store it, increment Y, compare yeah, because we can only compare with the A. TYA, transfer Y to A. So over here, did I click on the wrong one? Oh, here we go. Yeah, transfer Y to A. Compare to 32. Branch if not equal back to here to do another column. And decrement X. Now I have attribute table defined directly afterwards. But it's missing the heads up display. Just buffer in some zeros. Oops, that's all overwriting. Tiled at hood. Probably just works, huh? All right. Well, so that does all of the attribute or all the name table data. If we tell it to keep going, you just pretend there's 32 rows and 32 columns. It should fill in the since I've gotten to find one after another, I think it'll just go. And then here's setting all the attributes to 0. Don't want to do that. Fill checkerboard. Don't want to do that. Don't want to do that. Don't want to do all that stuff. Guess it worked. I didn't. Oh, we didn't import our data. Didn't look like it did it anyway. Everything looks like it's tile index 0. But let's get our data imported at least. I'm surprised I didn't have any errors. Like, surely I... Yeah. Forsaken Valley, CHR. Why does that look all weird? There we go. Everything's there. So look over this quick here. 2000. We didn't actually use temp. I have a hard time imagining I did the pointer right. So we load A with the high byte. We store it in pointer +1. Low byte and pointer. no idea what I'm doing here. So got a breakpoint. How do I see? Watch. Yeah, I don't know what I'm doing here. Anyway, let's pointer was $9.10. Yeah, I just need to get more familiar with CA65, and messing would help. Yeah, everything is 0, 0. I don't even know how to specify hex in here. Anyway, I think I'm gonna call it a night here. Got myself used a Nokin ASM with 6502 somewhat recently, but that's what I've done my STM8 stuff in, but I don't really think it's gonna be CA65 is what I want to be using if I'm doing all assembly, and even if I'm not a BNC and then doing an assembly. So I might spend some time brushing up on some of my assembly over the next week. But got our hands a little dirty there. Got successful in loading up that attribute table, or creating the attribute table data, and importing it into our project. So we've got that. Now we're able to create screens in tiled. We have a tile set. We generate our attribute table data. We can bring these into our C project. I don't know what I'm doing in assembly. And start making some screens, start working on some scrolling, and get a sprite 0 hit. And now we can kind of dig into the code now that we've got some of the asset generation toolchain kind of figured out in terms of the graphics and everything. So yeah, thanks for tuning in, everybody, and have a good rest of your week, and we'll catch you next week, next Wednesday. All right, bye.